There are few topics as compelling as extraterrestrial life, right? And when news on the topic lands, it tends to do with an impact heard around the world. Such was the case in June of last year, 2024, when a research team, they announced that they detected compelling signs of Dyson spheres. And as far as reality-shattering discoveries are concerned, a Dyson-like construct, that would be the ultimate jackpot. The existence of such a megastructure would confirm not only extraterrestrials themselves, but a civilization that's vastly technologically superior to humanity. We're here today to confirm that the announcement does indeed hold water, and that there really is a possibility that Dyson spheres have been detected. But, as with all discussions surrounding the existence of alien life, the topic is a whole lot more complicated than the clickbait titles that circulated at the time. Dyson structures themselves, they're widely debated as a concept, and some in the global scientific community still associate them more with science fiction than science reality. But if this is the case, why are many credible astrophysicists still seriously considering that these things may exist, and even that they may be the first things we detect of our alien neighbors? So, in June 2024, a team at the Indian Institute of Technology, they made a pretty startling announcement. They detected 7 planets in the Milky Way that were candidates for advanced alien civilizations. The team published their findings in the monthly notices of the Royal Astronomical Society, explaining that after a year-long research project, they had narrowed down an extensive list to a handful of prime candidate stars. Now, each of the 7 stars had undergone a rigorous investigation, and after alternatives had been eliminated, it appeared that the stars may be home to hypothetical Dyson sphere-like structures. The investigation had been made possible by information gathered from 2 of the most advanced space telescopes ever deployed, NASA's Wide Field Infrared Survey Explorer, WISE, and the more recent European Space Agency's Gaia, which operated between 2013 and March 2025. Gaia in particular was key in the project, having been deployed as an astronomy tool designed to take incredibly precise measurements of the positions, distances, and motions of astral bodies. The result of all of that data was the creation of a large-scale 3D map of our entire galaxy, including over 1 billion astronomical objects, mainly stars, but also planets, comets, asteroids, and more. In detail, Gaia measured each object within its range around 70 times during the initial mission period, which was from 2014 to 2019, and many more additional measurements were made after the mission was extended for 6 more years. During the entirety of its mission, Gaia revealed tens of thousands of new asteroids, tens of thousands of Jupiter-sized planets, 500,000 quasars beyond the Milky Way galaxy, and despite being temporarily switched off for repositioning, it's going to continue to expand on the map in the near future. Particularly important to the topic at hand is that Gaia wasn't just detecting astral bodies in the visual range, but was also taking spectrophotometric measurements, meaning that beyond the positions and motion of each object, information returned likewise included luminosity, temperature, gravity, and elemental composition. It was this data that the team at the Indian Institute of Technology was sifting through for over a year, taking note of any inexplicable infrared wavelengths. Of the millions of stars investigated, the overwhelming majority had a reasonable explanation as to why they were emitting light in specific wavelengths. But after narrowing it down and eliminating false positives, the team landed up with 7 stars, those that clearly emitted infrared wavelengths, but had no clear explanation as to why. Via the process of elimination, the team concluded that the stars may be home to a Dyson sphere, a hypothetical megastructure built around a star to harness its solar energy. Now, you might be thinking, oh my god, the team are jumping to conclusions big time. But there's actually a very tangible relationship between stars and their emissions. The wavelengths emitted by stars tie in closely with their surface temperature, which in turn is determined by age, size, and composition. Therefore, should wavelengths be detected not tying into those characteristics, it's long been hypothesized that they may instead be infrared excess emissions, or IEEs. And indeed, it is thought that a Dyson sphere-like structure will produce IEEs when harvesting energy, and that those infrared signatures may be detectable at vast distances. Now, you're probably now thinking, well, Simon, there must be some other explanation for the infrared signatures beyond an alien megastructure. And, well, You would be absolutely right, you big brain. As explained by Jason Wright, co-author of the study and professor of astronomy at Penn State, quote, "There's a lot of reasons that stars might have extra infrared emission. Typically, it's because they're extremely young and they have a protoplanetary disk. A new star will temporarily be surrounded by a disk of dust and gas, and this arrangement naturally produces infrared." But Wright and his team carefully eliminated this obvious possibility before settling on their list of 7 mysterious stars, which is exactly why we're discussing the study in the first place. So, the question remains, what's causing the infrared emissions, and is the scientific community really considering the possibility of giant alien Dyson spheres? And the answer to the second question is, not only is the broader scientific community taking the possibility seriously, it's been taking it seriously for decades, and indeed that such structures might exist has been a guiding principle of organizations like SETI, the Search for Extraterrestrial Intelligence, for so long. From Star Maker to Freeman Dyson. The 1937 novel Star Maker by Olaf Stapledon is one of the most revered and controversial books in science fiction history, heavily influential to some of the greatest authors of all time, including H.G. Wells and Arthur C. Clarke. The deeply philosophical novel explores the advancement of civilizations over billions of years, culminating in the reader viewing the creation from the perspective of an inconceivably powerful intelligence referred to as the Star Maker. The book was lauded for its depiction of how a civilization may progress beyond where we are today, but was likewise despised for suggesting that the highest form of intelligence, a godlike figure, may be cold, calculating, and entirely uninterested in the individual lives that it creates. The philosophical implications of the book, they're best left for a different video. This is a space channel. What's most relevant to our topic today is that, according to Stapledon's prediction, as a civilization progresses beyond a certain point, it requires exponentially more energy to fuel its expansion across the cosmos. The only logical solution to these energy requirements is the capture of a star on a grand scale, and it's a concept that stood the test of time. The book describes that by encircling a star with light harvesting technology, the energy may be redistributing as required, allowing a civilization to advance beyond its home planet. Stapledon describes a gauze of light traps surrounding a star, though he wisely doesn't go into too much detail since he was well aware that what seems like ultra-advanced technology in 1937 would not hold up to later scrutiny. What Stapledon does specify, a detail still very relevant to us today, nearly 100 years later, is that any advanced civilization will eventually burn through all of its easily available resources. Fast forward to 1960 now, and physicist Freeman Dyson expanded on the story. Using Stapledon's fantastical ideas as direct reference, Dyson approached the concept from a scientific perspective, writing the paper Search for Artificial Stellar Sources of Infrared Radiation. In his paper, he more or less transforms science fiction into science speculation, if you will, likewise exploring the idea that entrapping a star is a logical step for any sufficiently advanced civilization. Dyson said, "One should expect that within a few thousand years of its entering the stage of industrial development, any intelligent species should be found occupying an artificial biosphere which completely surrounds its parent star." Now, importantly, in Dyson's view, creating a solid megastructure around a star would be virtually impossible, declaring instead that the most realistic implementation would be swarms of energy-capturing objects in a star's orbit. As such, the two most commonly referred to forms of this hypothetical megastructure are Dyson spheres, a solid object encircling a star, and Dyson swarms, multiple objects stationed in the sun's orbit. Also important, and one of the main focuses of the paper, is Dyson's proposal that such structures would be detectable at a great distance. He suggests that the structure would unnaturally dim the star to an observer and would likewise produce infrared wavelengths as a byproduct, which are now referred to as IEEs. Hence, Dyson suggested that detecting stars with these characteristics should be a priority, and it really is a big shame that he died before these new observations were made. As to what a civilization capable of a Dyson structure would look like, and what it would be capable of, Dyson didn't elaborate much, leaving the details open for further speculation. And this all brings us to a Soviet astronomer that tends not to get as much attention as Freeman Dyson, though he arguably did just as much for our perception of alien civilizations, and that is Nikolai Kardashev, who first extrapolated on Dyson spheres by creating a cataloging system referred to as the Kardashev scale. In 1964, he put forward the now much-referenced paper Transmission of Information by Extraterrestrial Civilizations, proposing that by using humans as a base model, civilizations could be categorized into tiers, referred to simply as Types 1, 2, and 3. Type 1, that's a civilization that potentially represents humanity at some point in the future, able to access all of the energy on our home planet for storage or utilization. Now, we're obviously not there yet. We're not even fucking close. But fingers crossed that we'll see some sort of major breakthrough at some point in the reasonably foreseeable future. A Type 2 civilization, well, that's one that can directly harvest a star, referencing Freeman Dyson's paper. This civilization would be capable of expanding through the galaxy in unprecedented ways to colonize other planets. A Type 3 ultra-advanced civilization, somewhere in the distant future as far as humanity is concerned, could capture all the energy in an entire galaxy, including every object within that galaxy, such as all its stars and even its black holes. Since Kardashev put forward his original paper, it has been elaborated on both by Kardashev himself and others. The tiers have been updated to include Type 0, 4, and 5 civilizations, and the categorization of each civilization has been expanded to include not just energy consumption, but computational growth, food consumption, and other relevant factors. Kardashev wrote follow-up papers in 1980, 1985, and 1997, and his papers played a part of the identification of unusual astral bodies such as pulsars and quasars. So, both Dyson and Kardashev are compelling in their prediction of Dyson-like structures, and at least part of the scientific community has been using these arguments as guidelines. At this point, however, it's time to pose a question that neither Dyson, Kardashev, nor even Stapleton really went into much detail about, and it's perhaps the most relevant question of all. Is a Dyson structure even possible? And could a civilization, no matter how advanced, ever realistically build such a thing? Is a Dyson structure even feasible? Okay, first things first. For every second that the sun combusts, it generates roughly 384.6 septillion watts. That's enough to power the entirety of human civilization as it stands for hundreds of thousands of years. Another way to look at it is that 1.8 billion SAR bombers are going off in the sun every second, and humanity is currently incapable of capturing even millionths of a fraction of that total. The lack of efficiency is not entirely our fault, given that we're only able to interact with sunlight on a highly directional and limited scale, with the vast majority of the energy just radiating out into space. For the sake of argument, though, let's assume that Earth was struck by some sort of crisis, and that all of humanity diverted its resources to creating a Dyson structure. Could we do it? And if we could, what would it look like? Well, we're firmly in the realm of wild speculation at this point, but the physics of such a monumental megastructure are surprisingly not as far-fetched as you might think, at least on paper. We do, however, have to draw a very firm distinction between a Dyson sphere and a Dyson swarm, as mentioned earlier. A Dyson sphere, a solid structure built around an astral body, as seen in Episode 4, Season 6 of Star Trek The Next Generation, one of the greatest episodes of that TV show, is overwhelmingly considered an impossibility, regardless of how advanced any civilization in question is. The Dyson sphere in Star Trek is described as being built from carbon neutronium, as having a diameter of 200 million kilometers and an internal surface area the equivalent of 250 million M-class planets, and as even supporting varying terrains similar to that of a naturally formed planet. We can probably all agree that the logistics of such a megastructure are insurmountable, with the first and most obvious problem being the raw materials required. It could safely be assumed that every planet in an entire solar system could be mined bare, and there still wouldn't be enough resources to construct a sphere with the required diameter. If the raw materials were somehow obtained and a star-encircling structure was built, the insane challenge of keeping the star centered within the structure would itself be impossible. A solid structure of that scale would not stay in orbit of its own accord, and the sun would either collide with the structure or the absurd gravity would tear the structure to pieces. More to the point, an advanced civilization would almost certainly not be able to attempt such an absurd project, especially when much more logistically sound alternatives exist, such as a Dyson swarm. So then, a Dyson swarm would be a swarm of solar energy gathering satellites positioned in the sun's orbit in much the same way communication satellites orbit Earth. In this case, a primary challenge would be that only so many satellites could be in orbit at any given time, with the potential for collisions being overwhelming. Now, you may suggest that perhaps the satellites could orbit at different altitudes to avoid collisions, but then we'd end up with lower altitude satellites blocking sunlight to those at a higher altitude, which would reduce efficiency. To cut to the chase, the solution most commonly tossed around in scientific communities is statites, or static satellites, which don't orbit a sun, but rather remain stationary, creating an enormous, unconnected spherical grid. Again, still very much hypothetically, a core of the proposed statites grid is the inclusion of solar sails. If you're not familiar, a solar sail is essentially a large, lightweight surface that acts as a mirror, translating the momentum of sunlight into the acceleration of an astral object. The idea has been taken seriously for decades, with NASA and other space exploration organizations experimenting with the idea since at least the 1980s. A key benefit is that a solar sail would provide modest but virtually infinite acceleration, making it perfect for a proposed Dyson swarm. Each node in the swarm would use the acceleration provided by the solar sail to achieve a balance with the star's gravity, thereby allowing it to indefinitely maintain its position and harvest energy. Now, skirting around the many other complexities for the time being and acknowledging that a Dyson swarm is certainly more feasible than a Dyson sphere, we do still have to overcome a major challenge. That a grid of statites itself would still require an absolutely enormous amount of resources. But the solution in this regard is actually nearer than you think, with serious talk already centered around mining resources from asteroids and other planets. A few startups already exist exploring this very concept, for example Astroforge, TransAstra, and the Asteroid Mining Corporation. None of these companies are suggesting that the resources go towards Dyson swarms, but for our hypothetical discussion, a planet such as Mercury, nearest to the Sun, could potentially be mined and the resources put towards a swarm of statites. As for how we might engage in this massive mining operation, there are two options that seem semi-feasible: manned space missions or autonomous swarms of robots. Focusing on the first option, let's turn to the 1976 book, The High Frontier: Human Colonies in Space by American physicist Gerald O'Neill. It just so happens that O'Neill explored the idea of space colonies in great detail, proposing that the moon be mined and the resources be used as a stepping stone for more ambitious space colonizing missions. The most commonly referenced concept in his book are the so-called O'Neill cylinders, two counter-rotating cylinders, each 6.4 kilometers in diameter and 32 kilometers long, connected via a central rod. O'Neill predicted that the rotation of the cylinders would counteract gyroscopic effects, essentially providing artificial gravity for the space colonist families living within. And fascinatingly enough, O'Neill's physics actually seems to check out, suggesting that a mining operation of this nature could hypothetically really be built. In fact, the concept is so sound that it was presented at NASA's Turning Goals into Reality conference in 2000, rebranded as McKendree Cylinders by NASA engineer Tom McKendree. Meanwhile, in 2020, Canadian bioethicist and transhumanist George Dvorsky played around with the idea of sending autonomous robots to Mercury. His blog post, How to Build a Dyson Sphere in 5 Relatively Easy Steps, outlines his theoretical plan as follows. Number 1, get energy. 2, mine Mercury. 3, get materials into orbit. 4, make solar collectors. 5, extract energy. He elaborates on this, quoting, "The idea is to build the entire swarm in iterative steps and not all at once. We would only need to build a small section of the Dyson sphere to provide the energy requirements for the rest of the project. Thus, construction efficiency will increase over time as the project progresses." Now, his tone is a bit tongue-in-cheek, however, as he goes on to say, "We're going to have to mine materials from Mercury. Actually, we'll likely have to take the whole planet apart. The Dyson sphere will require a horrendous amount of material, so much so, in fact, that should we want to completely envelop the Sun, we are going to have to disassemble not just Mercury, but Venus, some of the outer planets, and any nearby asteroids as well." Alright, getting back to the topic at hand, as far as Dyson swarms being feasible is concerned, we can say, perhaps, under the right circumstances, at some point in the future, humanity may have the available technology and resources to make a project like this a reality. And this brings us back to the original question, whether the team at the Indian Institute of Technology is detecting something similar created by an advanced alien civilization. The answer, not too surprisingly, is that yes, it is possible, but no one is willing to commit to the idea. Are we detecting Dyson spheres? Okay, going back to the original report made in the monthly notices of the Royal Astronomical Society, the research team did go above and beyond to avoid blowing the situation out of proportion. The lead authors made very clear that although they've ruled out known natural phenomenon as an explanation for the unusual infrared wavelengths, there is still plenty more work to be done before any definitive conclusions can be drawn. As we speak, the team is working on gathering additional information, cross-referencing their study with other similar projects, and it all still has a long way to go before additional reports are published. With all that being said, there is still a real possibility that the detected anomalies represent Dyson-like structures. Lead study author Mata Sauzo, a doctoral student in the Department of Physics and Astronomy at Uppsala University in Sweden, said, "It's difficult for us to find an explanation for these sources because we don't have enough data to prove what is the real cause of the infrared glow. They could be Dyson spheres because they behave like our models predict, but they could be something else as well." In favor of the anomalies being Dyson structures is that all the identified stars are red dwarfs, which happen to be the star most commonly found to have orbiting exoplanets. This means that the chances are good that these planets are habitable and may even be home to alien civilizations. Also adding to the intrigue is that a similar study was done prior to the most recent by a team at the International School for Advanced Studies in Trieste in Italy. The team on this occasion separately came to the same conclusion, that there are inexplicable anomalies that fit the description of Dyson structures. A researcher working on this study, Gabriella Cantado, said, "We've got 53 candidates for anomalies that cannot be well explained, but can't say that all of them are Dyson sphere candidates because that's not what we are specifically looking for. You need to eliminate all other hypotheses and explanations before saying that they could be a Dyson sphere. To do so, you need to also rule out that it's not some kind of debris disk or some kind of planetary collision, and that also pushes the science forward in other fields of astronomy, so it's a win-win." End quote. Although, maybe not the win of there actually being intelligent alien life. An important point made by Cantado is that she and her team weren't specifically looking for Dyson structures, and realistically, neither are most astrophysicists. As opposed to identifying alien megastructures, astrophysicists are far more excited about the abundance of highly accurate, new data generated by Gaia and what that data is doing for our model of the galaxy. Even still, the Dyson structures haven't yet been positively identified puts something else important into perspective, namely that Freeman Dyson once suggested that harnessing the energy of stars is inevitable for advanced civilizations. If that sentiment were true, a structure of this type would almost certainly have been identified by now, given how frequent they'd be throughout the galaxy. Study co-author Jason Wright said, "The importance of this work is that it provides the first strong evidence that there are not a lot of Dyson spheres in our galaxy, contrary to the expectations of some that they might be an inevitable end state of technological species expansion out into their solar systems." The candidates Matthias has found are important because whatever they are, and they are likely stars surrounded by material from some sort of rare event like a planetary collision, although they could be Dyson spheres, are rare and interesting objects worthy of further study, for instance by the James Webb Space Telescope. End quote. Meanwhile, Saman Majumdar, who worked on the paper alongside Jason Wright and Matthias Suazo, put the scope of the study into context. He reiterated that his team had investigated 5 million stars catalogued by Gaia and that the work had taken his team over a year. He pointed out that 5 million is a fraction of the hundreds of millions mapped by Gaia, and that the dataset used by the team really is just a drop in the ocean of the broader picture. He elaborated that the paper his team published is barely scratching the surface, and that drawing any conclusion or making any implications based on the currently available data would be extremely premature. As with most research aimed at better understanding our universe, there is years, if not decades more work to be done before scientists are willing to put forward a hypothesis or make any suggestions regarding Dyson spheres or Dyson swarms. Both the team at the International School for Advanced Studies and the Indian Institute of Technology are waiting for additional information from the James Webb Space Telescope, but that will likely be in the far future, given how long the waiting list is. The most recent information on the topic, it came on May the 23rd, 2024. A response to the original paper suggesting that at least 3 of the 7 planets may be hot dogs or hot dust-obscured galaxies. This explanation isn't definitive, so it is, as with all other discussions surrounding the existence of aliens, a matter of waiting for the discussion to progress, really. Given how long the topic has already been deadlocked, it isn't impossible that humanity itself sets off to attempt a Dyson-like structure before we even find them elsewhere. Thank you for watching.